Let's start with the water again. So firstly, I would like to say that water is very important, as you know, and without water, there is no life. So that is why in the within Nexus, water, energy, food, ecosystem Nexus, water is the foundation because it is essential for food production, energy generation, and ecosystem health. Regarding food, of course, agriculture consumes more than 70% of global fresh water. Inefficient irrigation, unfortunately, waste water and energy. Regarding energy, water is needed for hydropower, cooling thermal plant, and producing biofuel. In terms of ecosystems, polluted water destroys our biodiversity, unfortunately, while healthy ecosystem naturally purify water. Now, according to the World Global Green Building Council, there are 4 challenges of the global water crisis. First one is the water scarcity. Water scarcity, 40% gap between global water supply and demand by 2030. The second challenge is water equity, access and quality. And we know that 25% of the global population does not have access to safe potable water. Then another challenge is the resilience and climate change. 90% of natural disasters are water related now. For example, flooding, drought, and so on. And then the last challenge is greenhouse gas emission. 10% of global greenhouse gas emission come from global water use, storage, and distribution. So, where water stress will be highest by 2050? This projected water ratio for human water demand to water availability show that several countries in the world will be faced extremely high water stress, namely North African countries, as you see. Morocco is there also. South African, MENA region, as my colleague said yesterday, and other country will be also facing water stress at different degree, namely Australia, for example, Mexico, and other countries. So the situation become very serious and we should act. Then I will move to the one of the solution to cope with the water scarcity is that you should have efficient wastewater treatment and reuse. But what is the situation of wastewater treatment in the world? In this figure, we see that only 56% of global wastewater was treated safely in 2020, with the big difference depending of the region and of course, if when we have developed country, for example, North America and Europe, we already reach 80%. But some countries like Sub-Saharan Africa, only 20%. And if we check for the Northern Africa, Northern Africa, we are almost at 63% for wastewater treatment at different degree. So we still far from achieving the Sustainable Development Goal, the SDG number 6, to have clean water and sanitation for all. Of course, we already implemented several conventional wastewater treatment in developing countries, but why such conventional wastewater treatment fall short? There are too many challenges. Firstly, high energy consumption. Conventional wastewater treatment require intensive aeration, pumping, chemical treatment, and all this have a negative impact on the water nexus, and it increase energy demand, contributing to carbon footprint. Another challenge is their conventional wastewater treatment are costly infrastructure. They are expensive to build, operate, maintain, mainly in rural area of developing countries. And the impact that limit the widespread adoption, leaving many without treatment access. Another challenge that such technology are unsuitable for rural peri-urban areas. Another challenge that limited, we sometimes we have limited pollution removal that make the wastewater not really well treated, and we struggle with emerging contaminants such microplastic and pharmaceutical, and the impact, of course, is negative on the water nexus, as we will have pollutants that remain in water, harming ecosystem and food safety. Another challenge is that the low reuse potential, because treated water often does not meet reuse standard for irrigation. And of course, the impact on the water nexus is that we are wasting the opportunity to support agriculture and water security. And another challenge is that the environmental pollution risk. When we discharge partially treated water, we contribute to the eutrophication and waterborne diseases in fresh water. And this also have a negative impact on the water nexus, affecting aquatic life, drinking water source, and ecosystem health. That is why we should look for sustainable solution, and among this solution, nature-based technology could be a sustainable solution for wastewater treatment. Why? Because they are low-cost alternative. We mimic natural processes, and we enhance water use within the water nexus. Nature-based solution, of course, make people working with nature, and this will reduce gas emission, will also permit control of flood and erosion. We protect our coastal area and so on. Then we contribute to improve the human well-being and our biodiversity. Then we contribute to the sustainable development. So there are too many nature-based solutions. I will focus my speech on those in relation with wastewater treatment. And we can classify such nature-based technology in two groups. there are some system based on water-based system, and we have other group substrate-based system. So the example of water-based system, we can have ponds like stabilization pond, for example, with microfit or macrofit using a plant, of course, and we can have hydroponic and so on. And we have the other group of system, the substrate-based system, consists of using substrate, soil or sand or gravel to filtrate water, and we can combine use with the plant also. And there is also the possibility to combine both kind of system, water-based system with substrate-based system, and even such nature-based solution could be also combined with the conventional technology. And in this slide, just I would like to show one type of nature-based solution, like constructed wetland. Constructed wetland is a wetland. We mimic a wetland, a natural wetland, but we put it as artificial wetland, as we can use it to treat wastewater. And according to this review done by UEOL in 2023, there are at field scale 38% constructed wetland in Europe, 30% in Asia, and 14% in North America, but only 8% in Africa. Even that such technology are more adapted to the African continent. And the photos show constructed wetland integrated into the public landscape at Kanshan Culture Plaza wetland in China. In Morocco, such technology, we start doing research on constructed wetland in 1984. Just at, we start at Cadi Ayyad University and other institutions. We experiment at lab scale and pilot scale different kind of systems, of nature-based systems. But in only on 2000, we implement a field scale reed bed as tertiary treatment in a municipality in Agadir city and at the Agronomic Institute Hassan Douala. So that is the first field scale or large scale system implemented in Morocco. Here are some examples of constructed wetland with the floating plant, floating macrophyte, Acornia crassipes, which is an ornamental plant. There is, as you see, a bigger plant in China. That is another example in Florida using another type, another species of macrophyte is Nuphar lutea. You see as tertiary treatment of wastewater. And also another example using another type of plant is the submerged floating macrophyte that live inside the water. That this example is in Montreal in Canada, and also in other area like Austria, Denmark, and other countries. Here in Thailand, in Bangkok, also we use different emergent plant, as you see, reed bed, tifa, donc all the plant. There are a multitude of a plant, of species of plant that play very interesting role in removing pollutants from wastewater or polluted water in general. Here is some wastewater treatment plant implemented in Morocco. I give some example. For example, this constructed wetland implemented in the province of El House, not far from Marrakech. This project, of course, was funded by the USAID. And the university, with my research group, we work with the association of the three villages to develop this project and get the budget to implement such technology in Morocco. There is another example of constructed wetland in another village using plant and substrate to treat domestic wastewater in rural area. Why such technology is adapted to rural area? Because still we have in Morocco delay in wastewater treatment in rural area. We make a lot of progress in urban area, but we need more effort. We need more technology adapted to rural area to develop sanitation and wastewater treatment. So here another kind of nature-based solution that could be used, and this technology is called multi-soil layering plant that we developed for the first time at Cadi Ayyad University in collaboration with our partner, Japanese Shiman University from Japan and Office National of Drinking Water and Electricity in Morocco. And this technology is substrate based. We don't use plant in this technology. It consists of layer of soil, gravel, and other ingredient. And as you see, the system is composed with vertical flow multi-soil layering system and combined with horizontal flow. And the treated water is reused to watering the landscape in one of the institutions of Cadi Ayyad University. Donc, we implement the system inside the university and we obtain very good result. And we start the system since 2016. But now the technology is implemented in some rural commune in Morocco. So here another example of implemented nature-based solution is combining this technology, MSL technology, with the constructed wetland in a small village, also here in the area of Marrakech. Recently, we start working using nature-based solution to remove cyanotoxin and cyanobacteria from surface water. As you know, due to anthropogenic activity and global warming, most of the lake and dams, we face eutrophication due to the development of harmful algal bloom. And this phenomena is global, not only in Morocco. And we were the first testing this technology, which is really a nature-based solution to remove harmful cyanobacteria, and we obtain a very good result. The system we start at lab scale with my PhD student, and then we move to field pilot scale at the field, and we succeed to remove some cyanotoxin and cyanobacteria, mainly when we use a horizontal subsurface flow system, as you see here, and we treat the water, the contaminated water from Lala Coast here in the area of Marrakech, and all these results are already published, and you can you can consult the publication, and all people interested, I can send them this publication. So that is, but how to improve treated wastewater? We need smart solution. How can smart solutions strengthen treated wastewater? In the era of artificial intelligence and digitalization and so on, this smart solution like AI and sensor are very important to real-time monitoring of water quality, predictive maintenance, automated treatment adjustment. And this will have a great benefit on the Wi-Fi nexus, for example, on water, that optimize treatment efficiency and reduce water loss, of course. Among the smart solution, solar energy also. Solar energy powers decentralized wastewater treatment plant, reducing reliance on fossil fuel, and the impact, the benefit for the Wi-Fi nexus is that we lower treatment cost and carbon footprint. Nutrient recovery is also one of the smart solutions. We can extract nitrogen and phosphorus from treated wastewater for use as fertilizer, and this will support sustainable agriculture and soil health. Also, water reuse, treated water could be reused for irrigation, industry, or aquifer recharge, and then we reduce freshwater extraction, preventing depletion. All this can have a benefit on the Wi-Fi nexus. In conclusion, I would like to say that treated wastewater is one of the key solutions for securing water, food, energy, and ecosystem. Smart and nature-based solution like constructed with land and multi-solar technology enhance efficiency, affordability, and sustainability. And investing in wastewater reuse, strengthen agriculture, reduce energy demand, and protect ecosystem. And thank you for your attention.